I'm sure I'll be able to recover. So I thought it was a good idea to switch to a Mac just recently, and apparently that was not such a good idea. I'm just kidding. Let me just log back into my machine here. We're going to be talking about C# and what's new in C# as a programming language. I generally joke that C# is turning into F#, and that's not necessarily a bad thing. Because taking inspiration from other programming languages that are available on the market, like F#, Swift, Kotlin, Java, and so forth, it's a good thing that the language designers keep talking to each other and looking at each other's programming languages. So hopefully, in the next few years, what we'll see is that we'll get more features in C# that are inspired by programming languages like F# and taking inspiration from all of that, which is not necessarily a bad idea. So fortunately enough, this machine booted up rather quickly, and hopefully I've recovered this. Let's just resume this as well. All right. So we're going to be talking about what's new in C# and things that have been added to C# as a programming language over the past few years. We're going to be going back a little bit further than C# 9 just to get a little bit of an understanding of some of the features that have kind of built up to what we're going to see in the next coming versions of C# as well. My name is Filip Ekberg. I've written a book on C#. I've got plenty of Pluralsight courses on the topic. So if you like my stuff, feel free to reach out and ask questions afterwards. If you don't like my stuff, you can tell me as well. Send me an email, talk to me about what's bothering you, what kind of things you're facing in your daily work that you'd like some help with. I love discussing programming languages, love talking about C# and .NET and the future of mobile development and all of that. But today we're going to be focusing on C# and what this language is becoming and things that have changed over the past decade or so. If you're a developer that have worked in C# for the past 10 years and maybe been out of it for a while, it can be quite hard to get back into it and understand where these new language features all make sense. So hopefully after this session you will get a little bit of an inspiration as to where these features make sense and how to add them to your application. Some of these language features will change how we look at the architecture of an application. Some of them change because of the available tools to us and the available machines and where we want to target our applications to be on. As an example of that, 15 years ago, maybe mobile development wasn't as big as it is today. Obviously, it wasn't because it wasn't as accessible. So now when we have mobile applications, we have IoT devices, they all need to consume resources asynchronously. So why not make it a part of the language to allow us to do that? So async and await was introduced in C# to make that easier. And there are more language features like this that quite drastically change how we build our software. Ultimately, it means that we can write less code to do the same thing. Hopefully, it's going to be less error-prone, and we can achieve the same result with less code and less errors. But that also means that we need to understand exactly what all of these features are doing. Another example of that is pattern matching. It's also generics. They drastically change how we look at building our C# applications. So how do we keep track of all of these different language features? And what about if I have opinions on what they're adding to C#? I know we're developers, we all have opinions. But if we have opinions on what's coming in C# and we want to participate, maybe even help build the next version of the compiler, we can jump onto GitHub and do that. There's a Roslyn repository, which was the code name for the rewrite of the C# and VB compilers. We can participate in discussions and look at the language design meeting notes and understand the reasoning behind why certain language features are added to C#. This is also a good place to learn exactly how to use them and where they would fit in different types of applications. There are many developers that join the discussions to just learn from others how this would be applicable in their applications. So if I'm not interested in just jumping on GitHub and implementing language features in the compilers, I just want to use these in my new applications. It's a little bit different than what it used to be. So now we have to be on a very particular version of both .NET and Visual Studio to be able to leverage these language features. If we want to use C# 8 and use the nullable reference types, for example, we have to be on .NET Core 3.0 and later. The reason for this is because some of the features that the language allows you to use requires both updates for the SDK as well as the runtime. The runtime will have to understand exactly how to run certain things. But most of the language features that we use in C#, they're just compiler magic, or it's just what the compiler is doing. It's just translating your C# code into IL. So what if the IL that it produces would be compatible with an older framework or an older runtime? While it's an unsupported case, you could use C#12 for a .NET Framework 2.0 application, as long as you're using features that are compatible with that runtime. So I'm not saying that you should do this, but you can. Which means that the only reason for upgrading for the new .NET versions would, of course, be performance, but if it's for the language versions, you only need to update or jump onto the newer version of .NET if you're using one of those features that are requiring a runtime change. So before we jump on to C# 9, 10, 11, and possibly what's happening in 12, I'd like to just talk about a few highlights from C# 8, which set the scene for what's going to be developed on for the next few years. So in C# 8, we got quite a lot of language features. Read-only members, default interface methods, or default interface implementations, depending on where in the documentations you read about this. We've got something called a switch expression, which changes how we use pattern matching. Pattern matching is a concept that's been available in many other programming languages for a very long time. And in C# 7, it became a first-class citizen in the language. But it's constantly being developed. So that's why we're going to take a look at exactly what this is as well. We're using declarations, static local functions, nullable reference types, which changes how the compiler looks at all your reference types. You know, if you're creating an instance of a class, that can be set to null. With this language feature turned on, the compiler will now assume that you've always set this to an instance, which is good, because then we can avoid potential problems. But we'll get into that soon. We also got a way for us to work with streams of data, disposables for asynchronous programming, ranges and indices, and null equalizing assignment. So being the 8th iteration of the language, we're not going to be looking at all of these features, but being the 8th iteration of the language, there's still quite a lot that's been added to it. And we'll continue to see more and more features added to C#. Now, before we get to the more useful language features, there's an interesting language feature that kind of illustrates why you would need to be on a later version of the runtime. So with C# 8, we got this thing called a default interface implementation or method, depending on where you read about this. So why this is interesting is because it kind of divides developers into two different camps. Some developers really just don't like this language feature at all, and the rest really don't like it. I'm kidding. There are some use cases for this. So default interface methods means that I can now change my interface and supply it with a default method implementation. While I'm using an expression-bodied member, I've now extended my interface with an implementation detail. So why is this such a big deal, and why would this require a runtime change? So prior to .NET Core 3.0, the runtime didn't know anything about how to execute a method from an interface, because that was just a contract to determine what the actual implementation, the class, the instance, what that would have. So while this is a good idea, the problem is that the tooling in Visual Studio, for example, it doesn't tell you if this is available. So imagine pulling down a NuGet package and update. There's a default interface implementation on that NuGet package. The Visual Studio won't tell you that it's there. So instead, it will just use that default implementation. So to solve this, you all have to read the documentations, like we all do when we're updating our packages. Everyone's reading the change logs. If you're saying that you are, I know you're lying. Now, an important feature added to C# 8, which has been changed now over the last few language versions as well, were improved upon by adding more features to C#. It's now coming to a state where we can write applications where we really avoid having null reference exceptions and null at all in our language, in our programs. The nullable reference types was introduced to help us avoid a very specific problem. Has anyone in here never seen this happen? You're lying if you are. I think all of us have probably ran into a null reference exception. Otherwise, maybe this is your first week as a developer and I welcome you to this world. Tomorrow you're going to see this in one of your solutions. So this isn't only the problem with allowing nulls in the language. Other languages like Kotlin make it really hard for us to use nulls. The compiler will smack you on the fingers if you try to. You have to explicitly say that this here can be null and I can use null in this context. But the problem with nullability is also that it encourages that we add null checks all over our code, which clutters the code. It makes it harder to read and understand exactly what's going on. What about if I can turn this around and put the responsibility somewhere else? I could tell the consumer that you have to explicitly say that you're passing null here, and I've handled that case. And honestly, it's quite ambiguous, right? So what does it actually mean to return null from a method? So imagine implementing a repository. You communicate with your database. I know many developers, myself included, wrap everything in a try-catch block and just return null from the method if there was a problem. Now, how would the consumer of my repository know if the object wasn't found or if there was a problem? Now, obviously, it's a bad design from my part, but I know this happens quite a lot. There are better alternative ways to do this. We can, with pattern matching now, say that we return a not found, user unauthorized, user removed, or whatever. So many different ways to build this architecture. It also encourages mutability. If I allow a property to be set to null, then there's an assumption that sometime this is going to be changed to, in fact, have a value. If that's not the assumption, then you can remove the property completely. And of course, this is a problem with multi-threaded applications, especially if you're doing async in await and a lot of multi-threading. So, of course, this here isn't a big problem. Like, I can null check. I can have a lot of code like this here. And someone in here much smarter than myself is going to tell me that I can write this a little bit prettier. Sure enough, I can use the null conditional operator and write this a little bit better. But what if I can indicate to the compiler that I promise that person, address, and street will never be null? At least that's my assumption. How about I tell the compiler that you can try and keep track of the state of nulls? We can do this by enabling the nullable reference types, and this is the default since a few versions back. So if you do file new project, this is going to be turned on. This here is the compiler directive to turn it on or off for one line, one method, an entire file. But per default, it's enabled in your csproj file. So let's jump over to Visual Studio, which I had started earlier, but now that this crashed, let's see if I can boot this up pretty quickly. So in the csproj file, this is now hopefully still turned on or turned off. And we can enable and disable this wherever we want. So let's say that I have a project here called nullable reference types. I'm going to go into this csproj file, and I have these two properties. I can say nullable enable. It's all commented now. Before I enable this, I just want to show you the file itself or the class. So this is a very simple code file. There's no issues. There's no compiler warnings, no errors, nothing like that. Simple class. It's a simple usage. I'm returning null here because that's always a great idea. So at a first glance, like, this looks like code that we've all written for a very long time. But if I now enable this language feature, which is the default from C#.NET 6, so going to be turned on by default, now I have a couple of warnings. Look at this. So now it's telling me that you have some non-nullable properties. You should probably attend to these and fix this. How many of you are always fixing your warnings? Ha! Right. I don't trust that at all. I'm kidding. So you can have style cops and whatever enabled that tells you that this is a problem. But what I like to do is that I'd like to go back to this to really ensure that this is visible. I'm going to treat warnings as errors. And now, if I go back to the correct file, this will now be a compiler error instead. So now I can't even compile my solution. So if you brought your laptop with you today, and you're using an older version of C# or .NET, go into your company projects, enable this, check in the code, and take a long weekend. And then when you come back on Tuesday or Wednesday, either someone's fixed all the null reference problems or you're out of a job. The first would probably be better. But now that I've enabled this here, surely enough, it's great that it's telling me that there's a problem. The problem here is that the compiler can't ensure that I've set this to a proper instance. And the way to do that is, of course, to introduce a constructor. Now the compiler error moved somewhere else because the constructor should be in charge of setting these values. But if I start adding, first here and string last, I have to set these two. I can't even type and talk at the same time. Let's do first name is equal to first. Last name is equal to last. And now there's no more compiler warnings or errors. The problem with this approach is that I've now changed the contract. So whoever's using this class will now have to go ahead and change all over the place, which is not necessarily a great idea. So how do we solve this? Well, with C#8, it wasn't really possible to solve this in a nice way. You could, of course, say that, well, I want to allow this to be null. So nullable reference types, nullable value types, you can just add the question mark, and now that can be set to null. So if I start adding question marks all over my code base, now all of a sudden I'm back to where I were prior to enabling this language feature, which is slightly true because now I've moved this warning to somewhere else. So whoever's using first name will have to ensure that it's properly null checked. I don't particularly like adding the question mark like this here, so instead, we'll do it for one of them. But I'm going to add two more language features, one that was added in C#9 and one that's been added in C#11. So let's say for first name should be required. If I add that, the warning is now disappeared. So whoever's creating an instance of this class are now required to set this to an instance. And I can also introduce a C#9 feature called Init only to ensure that once you've set this to a value, you cannot change this. So effectively, I made this immutable. Should probably do that down here for last name as well. It's better to create a new instance of this details class rather than changing the existing properties. And then for this here, it's complaining up here as well. So let's just make that nullable to illustrate what's going to happen next. So at another place in the application, I'm accessing the last name. And now the compiler knows that, hey, you should probably have set this to a value. What's interesting is that the compiler, if I set this person.details, if I set this to a new instance, this here is going to complain that I haven't supplied everything necessary because it requires me to also set the first name, right? Which is great. That's what I want. So if I say that I want to create a new instance of this, first name is required. I'm going to set that to a value. Then what happens if I set last name to something? Now it knows that I've set this to a value because it keeps track of this. It's called null state static analysis, which I'm not going to repeat again because it's the hardest thing to say. So that's a great thing. The compiler knows that I've now set this to a value. So what else can the compiler track? Well, it knows that if I perform a null check in another way, I can say person.details.lastname. If that is null, I can continue to the next one. That's not what I want. I can do this. I probably have to do details like that. Now it knows that I've performed this null check. But I can take it one step further to say that, well, what about if I use a helper method? So I can do argument null exception, throw if null, person.details. And I'm going to do the same, just to show you how this works, for last name. So the same thing here. This method that checks if it's null or not, how can the compiler know that it's performed a null check? How does it know that? There's an attribute used on this method to indicate to whoever's now using this and to the compiler that if this throws an exception, you won't be coming to the next line, and I promise that it's not null. Obviously, we can trick the compiler into thinking that we've performed a null check, but that kind of defeats the purpose. So it's very flexible, and it's a really great way for us to try to avoid these null reference exceptions. And with the required keyword added in C#11, this became kind of complete. Because what you had to do earlier was quite nasty. So if I remove the required keyword, and I want to say that this shouldn't be null, but I also want to get rid of this warning, so I could say, well, I'm going to set this to the default value, and I promise that default isn't going to be null, and now the warning disappeared. But whoever's using this here doesn't know. So to show you why that is a problem, we could say that this here returns null. The compiler now expects this to be set to an instance, but I can promise the compiler that I'm not returning null. So why is this a problem? Obviously, we're not smarter than the compiler, so the dammit operator, we should avoid that, especially with the new keywords in C#11. So instead, of course, we should return, I'm going to use yield return new. I can use a target type new expression, which was added in C#10, so I don't have to explicitly say which type I need to create. And since I removed the required keyword from down here, I'm going to set that to required again. Now it tells me that I should probably set first name to a value, right? There we go. So the nullable reference types is a great addition to the language, but was only really, in my opinion, completed now with C#11 released last year. And together with the target type new expression that reduces the amount of characters that we have to write, the code becomes rather nice. And before we go any further, so this here is a program.cs file. So before I jump back, this here is a top-level statement. Notice how you don't have to have that public static void main stuff. It doesn't have to be wrapped in a namespace. Nothing like that anymore. No usings at the top for the standard system stuff. This is the new way of building your console applications, or also what's known as minimal APIs. So again, I do encourage you to try this out and treat warnings as errors. You can turn this on as well in the project settings, as well as with the nullable reference types. And another just small note here on C#8, they introduced something called asynchronous streams. So they continue to add capabilities to language features that have been introduced over the past years. Like async and await was first introduced in .NET 4.5, so quite a long time ago in C#5. But now they keep adding things to the language to make it easier to consume resources. So for example, I can add the await keyword in front of a for each loop to indicate that I expect each element in this for each loop to be retrieved asynchronously, which is extremely useful. Imagine having a message bus in Azure, for example, or a message queue. You can say that I want to iterate over each message. I have no idea when they arrive, but I could basically say await for each message in my message queue. And the body of that for each loop would then run for each message as it's added in Azure. Quite handy. We've been able to write this code in different ways before, but now it's a little bit less code, it's more understandable. But you also have to understand exactly what async and await does and how it affects performance in your application. So with C#8 out of the way, we can talk a little bit more about C#9, which introduced a really important language feature called records, or record types. This is a way to more easily define a reference type in a little bit more of a concise syntax. It added the init-only setter that I just showed you. We had the top-level statement, which is a new way of writing that program.cs file. We got pattern matching enhancements. I haven't even showed you pattern matching yet, but that's a big topic, and we'll cover that in just a second. With C#9, they introduced more patterns to the language to make this a viable feature. They also added the target type new expression that I just showed you as well. And then there's a whole bunch of more language features, more targeted towards, I would say, lower level stuff. But again, like in the 9th version of the language, there's quite a lot added, right? It can't be easy maintaining such an old compiler and still adding really important language features. But that's why C# is still so popular, because it keeps adapting to the types of applications that we need to build and the types of tools available and the different platforms that require it. So we're going to be looking at records and pattern matching next. Pattern matching has been around in many other programming languages for a long time. Kotlin, Swift, among others. What this allows us to do is to look at an object or an instance and determine what that is. It could be, in this case, we could look at if the fruit is edible, if it has a certain shape, or if it's, anything you can think of. And I like to talk about pattern matching as a way for you to take a little bit of your code snippet and share that with the non-techies in your project. Maybe they shouldn't be allowed to add things to your patterns, but you can still talk about the expressions that you're using in a much more better way than it used to be. As an example, we can match on a type and what I like to call an attribute. And I'm not talking about the attribute that you have on top of a method or a class, but an attribute in terms of what something is. So in C# 1 through 6, we've been able to do this. We can say, give me the type if it's the type of what I'm looking for, and I can compare a certain property. Now, the problem here would be if that property only lived on the specific type that I'm looking for, I first have to perform that typecasting. And then I have to cast it to the correct type if I'm using it in some way inside that if statement. Something wrong with this, like all of us probably write this type of code, and sometimes I still do because I forget that pattern matching is so powerful. But with C# 7, they made this a little bit easier. And the goal here is to make it so easy for anyone to express themselves without having to write too complex code, and making it a little bit more extensible as well. We all know that it can be hard if you want to add just one extra clause here to the if statement or one extra thing to it. We have to write lots of tests to ensure that it works. But with pattern matching, it kind of quickly becomes obvious unless you're abusing the language feature, which I'm also going to show you how you do, so you can avoid doing that. Now with C# 7, they introduced the first version of this. So with a switch, or the normal switch statement, we can pass an instance and say that for the case of this being the type that I'm looking for, this is a type pattern, I'm going to capture this as the correct type. The compiler already knows that I'm looking for, in this case, an apple. It can then capture it to that particular type without me having to do anything. I can then access properties in that when expression. And then it's the concrete type or the correct type inside the case. Obviously, with C# 7, no one really wrote this because there's a lot more code to express the same thing. But this was the first iteration of pattern matching in C#. So with C# 8, they introduced a switch expression, which drastically changed how we write this. So instead, we have this line of code here where I expect a result coming out of my pattern matching code snippet. So based on my input, that's the object I wanted to create patterns for, I create this switch expression, which I fill with expression-bodied members. That's an example how this would look. Let's say that I want to get a string representation of my type. I can say, well, based on my instance of a fruit, create these different switch expressions. If it's the type of apple, then I'm going to return a string. So the right-hand side is what's returned out of this here. Could be a method call. Doesn't have to return a string. This is just a very simple way of doing this. Hopefully no one's now thinking that, oh, you can only match on a particular type. But surely enough, that's the most simple thing. That's a type pattern. So there's many different patterns available in C#. There's something called a positional pattern. If you use a method called a Deconstruct, you can pull an object apart and use it with what's called positional pattern. It's not used as often as the other ones, but I can show you that as well. We have a property pattern to match on property values. We can have a tuple pattern to match tuples with each other. We can do relational patterns. For example, let's say that I'm looking for users, and I'm matching on an authorized user where it's logged in within the last few days. Then I can do a relational pattern to say that you have to have logged in within 10 days. Which you can still express with a normal if statement, but with pattern matching, that little code snippet becomes a little bit more fluent and nice to read. And I can even use something called a conjunctive and pattern to say that, well, the user have to have logged in within the last 10 or 100 days. We can do list patterns to say that I'm looking for a list where the start of the list contains something or the end. I can slice off a portion of the list if it's the correct thing I'm looking for. And I can group these together with parentheses, and I can negate them with a not pattern. And there's all of these used together produces what's known as a recursive pattern. So surely enough, there's quite a lot of patterns available in C#. And we're going to be exploring some of them now. So let's jump back over to Visual Studio. And before we explore the patterns, I want to go through this file that I have here. So there's a couple of things happening in here. So first of all, there's not really a namespace declaration that you normally see. I'm using a file scope namespace at the top here to indicate that all the types available in this file now lives in this namespace. No more indentation, no more useless white space passed up to GitHub. right? Perfect. And then I have something called a record. So this was also introduced in C#9. The record type produces a reference type. It's a class with quite a lot of functionality behind the scenes here. So what this actually does, and let me see if I still have my browser open. Probably don't. Since my computer crashed, let's do to sharplab.io. Do I dare press restore? Probably not. Probably not. So just trust me what this is doing here. So what it's doing is that it's generating, first of all, it generates a reference type. Each of the things you see here, the properties, this here is known as the primary constructor or default constructor. So with a record, it doesn't have to have a body. Let's say we have record person. I can say string first name, string last name. What this here is now doing, it's producing a class with two backing fields that are init only, so it's immutable. It exposes them using a public property, so I can access first and last name. It also gives me value-based equality, so if I compare two instances with each other, it will compare the values of first name and last name, which is tremendously useful. It also gives me a way to get a string representation of this entire instance. Not JSON, but it looks similar. Great for logging, for example. Just be careful so you don't log any sensitive data. So with that being said, I've created this test result that has two primary parameters, or two properties that are required for this constructor. I've also introduced a body because it's normal reference type. It's a normal class behind the hoods. So I can add methods, fields, properties, and whatever I want. I've introduced a separate method here called Deconstruct. Now this here is a magic method. As long as you have a publicly exposed method called Deconstruct, spelled exactly like this, with two or more out parameters, what you will be able to do is, let me show you. I can take an instance of a test result. So I've already prepared that I have a couple of test results. Or test results is equal to results. This is an array of test results. If I do this, and I can't spell. Now, if I want to get these different, so the test date, date since, and archived, if I want to get that into separate variables, I can deconstruct this object. So I can do A, B, C is equal to test result. Test result. Now, this doesn't make any sense at all. So we should probably avoid such shorthand variable names. The problem here is Visual Studio isn't really telling me what it's being deconstructed into, except that I can hover this here and I can see that, well, the first thing is a date time offset, so that's probably the test date. I think the second one is an integer, so that would probably be the number of tests. And the last one is archived. Doesn't have to be the same name that I use for my deconstruct method, but basically, if I have this here, I can take my object or my instance and I can deconstruct that into separate variables, which is handy when it comes to pattern matching. So we can leave that for now, but that illustrates exactly what is generated by a record type. Now, there are multiple different ways that I can use pattern matching. I can use it with if statements. I can use them with my switch expression. So for example, let's say that instead of test result being my actual instance here, so I have created this method called getTests, just returns a couple of failed ones and then finally a passed test. Doesn't really matter exactly what this is doing. We can move that down there. Now, let's say that I want this variable here to contain a string representation of the result. I can instead say, well, based on what the first thing is that I get out of this, I can produce patterns to determine if it's a failed test. I can capture this. This here is called a declaration pattern to declare that as a variable. So failed. There we go. And I can find past ones. Right? So I can use the type pattern. And then I can use a discard. The discard means everything else. It means null. It means whatever. It's the same as var. So if I do the var pattern, that will also match on nulls. That's something that you should keep in mind. So if I undo that, I'm going to use the discard. And I'm going to say, if it's failed, passed, and in con. Oh, wow, look at that. I think it's the first time I actually succeeded spelling this word. Perfect. So it's inconclusive. Now, I can fill this with more patterns. So I mentioned that, well, this here is now using the type pattern, but maybe I want to be a little bit more granular. Maybe I want to also check a property. So we could say that, well, if it's failed, or rather, if it's failed, let's just remove this here to make it a little bit easier, or I don't care about the type. So this here will, first of all, it will ensure that it's set to an instance, and then I can access a property to say, well, if the number of attempts are more than 10, I'm going to consider that you failed this test. Right? So this here, not having set, passed, failed, or whatever here, this will match on anything where that property is set to 10. I could also say that, well, it has to be less than 20, because if you've done this more than 20, actually it should be less than, right? Less than 10. More than 10 and less than 20. You get the idea. If you've done this more than 20 times, like I don't care. Then I don't want to see you doing this test again. So between 10 and 20. So this is a very easy way for me to construct a way for me to express what I'm looking for. Like I can do this with an if statement, but it gets a little bit easier on the eyes just to look at it like this here. Now, I could also parenthesize this here. And this is something that you should probably avoid, because what happens if I negate this entire pattern? Similar to any language feature of C#. You should avoid abusing the language features and avoid writing code that doesn't make any sense. I've seen people abuse pattern matching to, instead of saying false for a Boolean, they do not true. Which works, but it's just more characters to say the same thing. So now this here is doing two things. We have the type pattern. It's recursively looking up the next thing, because it's an OR pattern. We're looking at the property, and we're using a relational AND pattern. So pattern matching in this case here is really powerful. Now, surely enough, that's on one object, and I can do the same thing. I can take this out. It doesn't have to be with a switch expression. I can say, well, if results is results dot first is, here we go. I can do that as well. I can use it with the if statements. I can use it with a switch expression. I can use this wherever I want. If you want a fancy way of performing a null check, you can say, well, if see, I can't even spell, if results first is set to an instance, that's the same as saying it's not null. Quite handy. All right. And now with C#11, what we got is something called a list pattern. So we got the normal type patterns, checking property values, the tuple patterns, and so forth. You can use all of that and explore that on your own. Now, but a newer thing in C#11 is a way for me to look at this array. So I've produced an array here instead of an IEnumerable, because it has to be an array in order for me to slice off some information, because I'm going to use more than one thing. So I could, for instance, say that, well, if, let's do if results, or result is equal to results, switch. And now I'm going to produce patterns for this, if I can spell. There we go. Now I'm going to produce patterns for this array instead. And what I can do now is to say, well, if the first value is failed, and I don't care about the rest, then I'm going to enter get this result. Right? If it's whatever, like I don't care, I can use the discard again. I can also say, well, if the first one is failed, I don't care about the last one, but I'd like to get the middle elements. So now it skips the first and the last element, and I'm getting everything else in the middle. So why is this a big thing or a big deal? Imagine instead of having this made-up test results array, it could have been the payload coming in from data. I know how long the header is. There's a couple of bytes that I'm looking for. This here could be the value of those first couple of bytes. and then I could be slicing off the information in the middle. And if this was a span, that would be a very memory efficient way to do that. So this was introduced in C# 11. So patterns in C# is powerful, and I promise that we'll see even more patterns being added in the next versions of C# as well. So with C# 9 out of the way, we can take a look at some more things from C# 10. Now, given that C# 9 introduced records that produces reference types and classes, obviously it would be a good idea to also allow us to do record structs, value types. They work similar to the reference types, but by default, the record structs aren't immutable. So you have to mark them as read-only if you're creating a record struct. A little gotcha. There's some other improvements. There's something called a global using directive. So if you add the global keyword in front of your using, then it will become available for all your classes in your solution or in your project. We saw the file scope namespace declaration, and this is a way, and was introduced because of minimal APIs. Minimal APIs is a way for you to produce an ASP.NET Core application in a program.cs file with just a couple of lines of code, like less than 10 lines of code. Many of these features are added to cater for that, to make it easier for many other developers to jump in and learn C# and use it for microservices or nano services, or whatever you want to call the new cool thing. There's an extended property pattern. So if I were to go back to my solution here, and this here's a property pattern, if I were to access another thing here, let's just say get type, for example, or if that was, let's just say that it had a length. If this had the property length, it would automatically perform a null check when I do a dot here, which is quite handy. So you don't have to do multiple null checks. They've improved some improvements to lambda expressions. You can do constant interpolated strings, which is a tiny feature, but still important. So imagine you have two constant strings and you want to interpolate that, for example, in this case, the version number. You couldn't do this prior to C# 10, which was a little bit odd. But a more important feature is inferring the delegate type. So this is the improvement to, well, this isn't the improvement because this is from C# 9. But in C# 9, you were required to specify explicitly which delegate type that you were using. So I could say func string of integer here, but instead, why couldn't just the compiler figure this out? It knows that I'm expecting a string to be passed into this anonymous method, and it knows that I'm returning an integer, so why couldn't it just infer that? And surely enough, that's what C# 10 is doing. So here is an example of a minimal API. Now, the minimal APIs is a way for you to create this ASP.NET Core application in a very tiny program.cs file. But they've added one feature at a time to the different versions of C# and to .NET, and they constantly improve upon this. So with C# 9, we got the top-level statements, which made this possible. But now with C# 10, they added attributes in lambda so that we can, in this case here, I can say that the parameter passed into this get method is coming from a header, for example, which is quite handy. So while C# 10 didn't introduce groundbreaking features like nullable reference types or record classes, it's still quite a lot of tiny changes to cater for the future. C# 11, on the other hand, introduced what I showed you earlier, the list patterns. And I have another example of this as well. What I didn't tell you is that I sliced off a portion using the slice pattern. So the patterns introduced in C# 11 allows you to grab that middle portion of the array and slice it off in a very memory efficient manner. You can do name of parameter, which isn't such a big deal. A big deal, though, is that they're now caching the delegates for static method groups, which is, if you've ever run into this, this could have caused a performance hit or a performance penalty. And now they're finally caching that. The required property were introduced in C# 11 to allow you to now use nullable reference types a little bit better. So I can say that this property is now required. The compiler in the Visual Studio will tell you that it's required. So that when you're creating this instance, either with a constructor or with a with expression, for example, it will tell you that you should do that. There's something called a raw string literal. static members and interfaces, UTF-8 string literals. Everything that's coming over the web is basically UTF-8. C# by default is UTF-16. So whenever you get a string into your application and you tell your ASP.NET Core endpoint to expect a string, it has to convert that into UTF-16 from UTF-8. Might sound silly, but in the grand scheme of things, that is a little bit time-consuming. It requires a couple of CPU cycles to do so, which is not necessarily what you want. So instead, we can have a UTF-8 string literal. I can say that I expect this string, or I have this constant string in my case here. I append the U8 after the string, and now this here is a span of bytes. Which again is really handy if you're working with interop with hardware, where everything comes in as bytes and you're looking for a particular payload, for example. I use this extensively, so I don't have to convert back and forth to strings. Makes the code a little bit more clean. There's generic math support, generic attributes, so I can now say that my class has a generic attribute, for example. I've wanted this feature since I started with ASP.NET MVC probably 10 years ago. It took a long time to implement. Maybe it wasn't important earlier, but now it is. There was something called parameter null checking. I don't know if anyone's ever seen this, but they removed this from the language. So let's go into, let's say this method here. Who is here? Doesn't matter what it's doing. It has a parameter. Imagine, so they removed this feature. Imagine if I just did double bangs. They had this in a preview version of the compiler. They were very sure that they were going to ship this. Many of the internal teams at Microsoft refactored all their solutions on GitHub to use this. What it did was that it automatically null checked on the parameter. So basically what this introduced was an argument null exception, throw if null, people. So this way you can do double bangs instead of having to write that entire code snippet. Many people didn't like this for the reason that it adds a little bit too much code that's potentially crashing, right? So this isn't really the best. Adding double bangs had a much bigger side effect than you might have hoped for. So again, like if we go into GitHub and participate in the discussions, we can influence what they're doing and why they would want to focus on a feature or why they might not, why that might not be a good idea. So many people reached out and now they removed that. So if you've been out of the game and you haven't followed what's happened for the past few years, they had to remove that because no one wanted it. So the list patterns, here's another example of that from C#11. So I have a list of names here. I can now say that, well, if the first one is Filip, I'm going to grab all the middle names, and then if the last one matches what I'm looking for, I can say that at the second pattern here, I can say I don't care about the first one as long as the second one is a particular value, and then it also followed by more of them. So I can do a lot of interesting things with list patterns, with all the other types of patterns as well. And this here worked with the array as well, which is why I can also slice off a portion of the middle part. And I think in C#13, 14, 15, and how much longer we're going to go, we're going to see more patterns added to the language as well, which is good. Now, raw string literals allows us to produce a string here. I have a 3 double quotes, and that allows me to then, in this case, write XML, which also has the capability of doing string interpolation. So I can inject my connection string into this XML here. Looks very much like XML literals or whatever you want to call them from VB. But you can write JSON, and Visual Studio has syntax highlighting for the code that you write in your raw string literal. Quite handy. So the UTF-8 string literals, here's an example of how to take my name and convert that into a read-only span of bytes. I can then use this payload to say that I want to find the index of the UTF-8 space. That's a very quick operation to look for it. And then I can say I want to, at line 7 here, I can say I want to grab my first name. So I'm using a range syntax to say that give me all the characters up until the space. And then on the next line, on line 9, I'm saying jump over the space and give me the rest. And what's interesting with this code snippet is that it's pretty much allocation free. There's a couple of variables declared on the stack, and obviously my name is allocated somewhere, but the slicing operation, the looking for the index, none of that has to copy any data over to another memory position. So they've done this extensively in .NET and in ASP.NET Core, and the performance is just shooting through the roof because they don't have to copy any memory over. There are some gotchas with this, but it's a really great way to work with data. So abstract memories and interfaces was also introduced in C# 11. In this case here, I have an interface that dictates that you should have an instance defined on your classes. But in older versions of C#, this didn't really give us a warning or didn't tell me anything. Much like the default interface implementations, it doesn't tell me that I have to add something. But if I mark it as abstract with C# 11, this is now going to tell me that the class person here doesn't implement that particular interface, which is a good addition. So now, with C# 8 through 11 out of the way, we've looked at some of the really important language features. A heavy workload has been put into doing pattern matching well, to get nullable reference types built really well, and adding support in the language to avoid nulls. And hopefully we can all agree that it's a good investment in the language. And what I think is great about all of these language features added to C# is that most of them feel like they belong in C#. And that's probably one of the challenges working on the compiler, that they have to make sure that it feels like a C# language feature. Surely they can take inspiration from Kotlin, Swift, Java, and many other programming languages, but it still has to, for a C# developer, feel familiar. And I believe most of these does. So what's next? We can jump onto GitHub and look through all of the different features that are coming. But out of experience, I know that many of the language features that are talked about and worked upon, they might be coming in the next version of. Like after, so we have C# 12 coming in November. But I would be surprised if the change set they've released now stays the same. Like, they have to ensure that the tooling is there, everything has to work perfectly well, and no bugs and no community backlash for some of these features. But with C# 12, we're going to see some interesting additions. So how about we take inspiration from records and introduce something called primary constructors on classes? Now, if someone's really sharp on the eyes here, you'll notice that I haven't written these in uppercase. So I have my class user, and there's a primary constructor that expects a name and a registration date. But with a record, I made them uppercase. Is this a spelling mistake on my hand, or is it just that they're different? The fact is that they are actually different. With a primary constructor on a class, all that's generated here are backing fields. So if I fire up ILSpy, we can see that this here introduced a constructor, and it also introduced the backing fields. But with a record, it introduced publicly exposed properties that were set to init only. But with this, they didn't want to make such a big change to your class or what's generated, so you have to add that yourself. I mean, as you'll see here, I can access these fields inside my override of 2 strings. So I could just as well have exposed a publicly exposed property and set these to the default value. They're also making lambdas a little bit better by introducing something called optional parameters or default lambda parameters. It's a small addition, but since we're doing a lot of minimal APIs and that's the next big thing, this is a good addition to it. So in this case here, I can say that my lambda has a default parameter, and if I call it with or without a particular value, that just works. So now there's 2 more features in C# 12 that I think are going to make the cut. There's this thing called alias anytype. So I could say, somewhere in my code file, I could say using point is equal to this tuple, or tuple, depending on how you like to pronounce that. So if it's the first time you see a tuple, this here creates a value tuple behind the scenes which has 2 fields, a field x and field y. But instead of having to create a wrapper struct or wrapper class, I can simply say whenever I refer to a point, that's going to then use my tuple, which is great. And if I append the global keyword in front of that, it's going to be globally available for my entire project. That's why I didn't have to do anything inside my program.cs file to use link, for example, because they're inferring where the namespaces are coming from, and they're doing a lot of that compiler magic that we love behind the scenes. Another feature that is possibly coming to C# 12 is something called Interceptors, which is also an inspiration from other programming languages. Like Objective-C, for example, has had this for a very long time. Imagine that I have this little code snippet here. Super simple class called a logger, which has a publicly exposed method called log, which takes a message. It then calls an internal method, which is simply throwing an exception. Now, I'd like to intercept this method call. I'd like to intercept what happens when you call log internal. So what I can do is that I can create something called an interceptor, simply apply an attribute called intercept location. In this case, and in this state of this language feature, I have to know the line inside this file, so line number 5. I have to also know the column or how many characters in that method signature starts. But I can write code that figures this out for me. And then what I'm doing is that I'm intercepting this using my console.writeLine code snippet that I have here. So it takes the class of logger, it takes the same parameter called a message as an input, and then I can use this. So the interesting thing with this, imagine that I pull down a NuGet package, and it just magically intercepts some of my method calls without me having to know about it. Sounds dangerous, but it's probably not. You can very easily say which kind of interceptors you allow in your application, so there's not really any security concerns. But it's interesting because this here now allows me to intercept this call and do other things. So with source generators and interceptors, I can use this to replace functionality or add functionality quite easily. And I do have one more feature I want to show you. I'll have to jump over to Visual Studio, and hopefully it's still there. There's this thing called a collection expression. I'm almost out of time, so I'll show you this quite quickly. So here, I've constructed an integer array with data and an IEnumerable of integer. I'd like to concatenate these two together. Previously, you had to write a little bit of particular code to do this, create a temporary list, add all the elements, or use link to produce this. Now, I can use a collection expression to say, hey, I want to grab everything from data and everything from more data and just create me a new collection. And this now produces, if I run this here, that should produce 1 through 10. So as you'll see here, it prints 1 to 10. Because I took all the data, 1 through 6, and 7 to 10, and put them together in one array. So just a little bit of a shorthand way of writing something that's quite nice. So with these features being added to C# 12, there's quite a lot happening to C#. It can be quite tricky to keep up. I've got a lot of courses on Pluralsight that I'll have to go back and update with some of these really new, interesting language features. But if you like my stuff, you can always check out my courses on Pluralsight. And it's interesting, because I always end with these slides, and I tell people to, hey, send me an email if you have any questions. And for the past 10 years, I've never gotten any emails. Do you know why? Because I forgot to put my email on the slide. Not the best thing. So now my email is here. Take a photo of that if you want to. I'm happy to discuss everything around C# and what's happening with .NET performance. There's a lot happening, and I just love talking about these different things. I hope you've enjoyed this and the conference. Remember to vote on your way out, and thank you so much for spending this hour with me.